Hello, everyone. I guess we're live now. Welcome to the first campfire that I, myself, will be hosting in Tyler's absence for this week. For those of you that don't know, my name is Emily Pillmore, and I am the Pact lead for Kadena. I run the Pact language and its various projects. And I am here with one of our lead developers, our principal developer even, Lars Kuhtz, who is, actually, I'll let him describe who he is. Lars, if you want to give your introduction.
Yeah. Hi, Emily. Hi, everybody. I'm Lars. I work at Kadena for, I think, almost 5 years now. Been mostly involved in building Chainweb, so our consensus layer. So that's my main area of focus. Before I worked for Microsoft, the cloud division. I worked at a startup where we built cryptographic tools and spent some time in academia. So that's my background. And yes, Chainweb Consensus is an exciting project. I've worked in it since 5 years. And
give yourself a little bit more credit. He was the main architect for how Chainweb works. It's quite cool. Welcome to the campfire, Lars. This is the first time that we've had you on the campfire, so hopefully we get into some interesting questions. For those of you that don't know, who want to continue, following these things, we do this every week with either somebody in leadership or a new partner or somebody we want to feature. And this week it's Lars. So let's head into the questions, and we can start. I think this one would be good. From Kadena Island, if I was a total newbie with the project, how would you describe and convince me that Kadena as a project is going to make a difference?
Well, I can mostly speak about the part that I worked on, which is Chainweb. So, Kadena has this kind of this big main kind of products Pact on the one side, Chainweb on the other. I think the company made innovations in both. On the Chainweb side, well, I can say what convinced me. It's scales Bitcoin. So it's a very conservative, I would say almost canonical approach to make Bitcoin scalable. Bitcoin has this big disadvantage that kind of, it is a completely new algorithm. It solves the problem of decentralized consensus in an adversarial setting. So it's an open consensus. Wherever in the world you are, you can just join the Bitcoin network. There's nobody already in the network who can prevent you from joining it. And that's a great thing that seems to work. And I think it's an elegant algorithm. Simplicity is something that we value in computer science. If something is simple, it's probably good. And the problem of Bitcoin is that it really doesn't scale. It's one chain. It's completely clogged. It can produce a block every 10 minutes. Maybe you can bring that down a bit, but there's a limit. And I think when you look at Chainweb, the algorithm, and the first time it was presented by Will, it was really like, yeah, that's how it should be done. And I think that's a nice thing about it. So we are doing Bitcoin. We are very conservative. We keep all the good things from Bitcoin, and we just add this little bit, or that makes it scalable.
Oh, thank you. It's good to hear that it's convincing for somebody who's been working on systems for 20 years.
Well, of course, and then there's Pact, and it has some things that the EVM had this idea, we are being the universal computer, and it was big and bloated. And then when Stuart presented Pact to me, and it's kind of the idea of having a smart contract language that is really just designed to be a smart contract language and being good at exactly that. That's also, I think it was, I'm not sure. I think it was the first smart contract language that was really designed from kind of the practical point of view, being a language for this task.
All right, let's move on to the next question. This one is actually quite interesting. From Almeric, is there a Moore's law to blockchain technology and programming languages? And if so, how does that impact Kadena's layer 1 solution in Pact?
I don't really know. Emily, do you have an idea
I think Moore's law in this case, so for everyone that doesn't know, it sort of refers to the maximal computing capacity of a single processing unit in the sense of like a CPU, right? You can only make the silicon go so fast. And we solved this, though Moore's law was effectively destroyed with the advent of sort of multi-core architectures. And in the same sense, I think that's almost a direct analogy for what Chainweb is in this case. You have various kinds of, procedural sharing in terms of like information sharing across cores, across shards, that all sort of work in concert to produce a singular output. So I think of Chainweb as a kind of single blockchain with many sort of sharded layers that share information that can parallel compute work for a final sort of singular network result.
That's actually a nice analogy, Emily. Yeah, I think maybe that's what the question is about, because we had the situations that Bitcoin was scaling and growing exponentially over several years, and more or less, and Ethereum, and at some point they hit the limits. This is maybe in a way how silicon hits the limit at when they can't make it smaller. Blockchain hits the limits when finally the blocks were so full and the gas cost skyrocketed, and then the only step forward was to parallelize things and find a way how you can efficiently parallelize, and still, of course, you pay a price for it. So transactions are not as strong and as fast, but you try to make. I think Chainweb does the same as cloud computing did for, or maybe multi-core on a processor level did for normal computing.
Yeah. One of the earliest things I used to say about Chainweb was actually like, Ethereum is trying to be the world computer, but we're trying to be the world multi-core computer. So in a sense, there's a maximum sort of processing capacity that can happen within any one paradigm. So say choose proof of work, proof of stake, whatever. You have a maximum sort of number that you can process in terms of how quickly information can propagate throughout the network, how quickly blocks can come in, how quickly things can be confirmed, and you have to make concessions about like the packet size, for example. What size of blocks that you're trying to work with, and in our case, I think we have the ability to parallelize, so we have a kind of as much sort of width within the capacity of the network as possible to sort of cram however many packets we care to over the wire. There is obviously a sort of network limit in terms of the capacity of various information channels, how quickly blocks and their information can propagate for 10, 20, 50, 100 chains. And that needs to be something that we keep in mind. And I think we do keep in mind with our, for instance, 30-second block times. We make sure that information propagates throughout the network in time. And so far we've had good success with 10 chains, with 20 chains. And I don't know. Do you see any problems scaling to something like 50 or 100 chains?
No, actually, we 50 chains is something I think it was exactly 50 chains. I don't remember the exact graphs that we used, but we had an earlier version of testnet was actually running on a much larger graph, and then for production we scaled it down to, because one shouldn't forget, even if you scale to larger number of chains, every chain comes as a constant overhead. So the costs are still there. If you would have to store the blocks for it. So it's not that there's no extra cost, but the point is you can scale. So you can essentially horizontally add new capacity to the system. So, but of course we don't want to add more than is needed. So we went for 20 chains, and there's still plenty of room on those 20 chains. So there's a lot of capacity available. And so it will take some time until we fill that up. But then we simulated systems up to 1,000, 2,000 chains. So we don't see in limits there. So there are actually internally already, even though Chainweb is a single process, so if you run a Chainweb node, you run a program. Internally, there are essentially already 20 programs running there. So it's it makes it more convenient at that point to run a node just as a single process, but we are ready to take that apart and run it, distributed over a network. And I don't see, there is some limit, sure, on the consensus side for synchronizing blocks, but we are far. First of all, I think we can improve that algorithm a lot, but I don't see currently a limit that would, have any practical relevance.
Okay.
Although, we, as I said, we certainly tested it for up to something between 1,000 and 2,000 chains. So beyond that, we haven't tested it. So one should be careful in kind of making claims. But I don't see a theoretical issue there.
All right. Well, thank you, Lars. Getting into layer 2s, we have a question from our YouTube stream. One Hit a Quitta asks, how is Kadena better as a layer 1 with Chainweb versus layer 1s that use layer 2s to assist with scaling?
Well, one thing is a layer 1. Our layer 1 is decentralized, so you get a completely different level of security than you have on a layer 2. On a layer 2, essentially, you have layers 2s usually are centralized. They are kind of controlled usually by a single entity. You might put some proof of stakes there also, but they are not backed by the same level of security than a layer 1. Also, when you go on a layer 2, you're living in your small world, and in order to kind of transfer funds or transfer liquidity or communicate in any way with other layers 2, you have to settle to layer 1. So there are certainly benefits of doing as much as possible, or everything that can be done on a layer 1. Otherwise, when it comes to finality or latencies until you have settled, there's certainly a limit on every layer 1. Chainweb increases bandwidth a lot and throughput, but there's a limit on how you have to wait a certain number of blocks depending on what is at stake. You have to wait longer, so that will never be like milliseconds or so. In that case, layer 2 makes sense, but I would say if you have a better layer 1, use it.
Yeah, fair enough. I think it's a little bit apples and oranges, isn't it? It depends on what you're willing to sacrifice.
Yeah. If you build a layer 2, put it on the better, on the faster and the layer 1 that provides more throughput, I would say. Why you would, if you have a nice layer 2, why you would put it on a layer 1, and you have 2 layers 1 you can choose from. Use the one that scales, I would say, if you need scale.
Fair enough. Here's actually a good one that you're uniquely poised to answer. How much do you want to answer a Caspa question, Lars?
Oh, I don't know that much about Caspa, I have to say. So, but maybe Emily, you know more. Maybe we can try together.
I don't think I'm qualified. I haven't finished reading the paper.
I looked into that stuff, but it's too long ago that I would feel confident to talk about details there.
Yeah, fair enough. All right, let's take one from Kadena Ireland again. Actually, let's do this one. As you previously worked as a senior software engineer at Microsoft, using that experience, in what way could you see Kadena and Pact?
In what way could you see? Well,
I think I'm going to rephrase this question.
Yeah.
Using your previous experience, in what way do you see your previous experience informing Chainweb and Pact?
Well, I think this is mostly about engineering. I worked at Microsoft as an engineer, so I learned a lot about engineering, and it's certainly interesting. Well, one thing is you'll see how big organizations work, but what is really interesting is you see how you have to work with big systems, thousands of computers. You have to deal with a lot of data. A lot of customers get very unhappy if there's a mistake. So you get a feeling for this level of quality and being data-driven, being careful. That's certainly something that helped when we built Chainweb. Otherwise, it's a new experience, because when you work at a big tech company, you usually build centralized services. You might have 1,000 computers, but you control them all. If something goes wrong, you fix a bug, you roll out a new update, we test it, and problem is solved. Chainweb is a P2P network. It's completely decentralized. When we have a bug, we can't just go and patch it on all computers because we don't run Chainweb, all Chainweb. We run a very small part of Chainweb. We have some nodes in there to see what's going on and, test our own stuff. But most of the nodes in Chainweb are not operated by us. So that's certainly a different experience from what I saw at big tech companies. But what I learned is, being data-driven, instead of, when you put something out, collect as much telemetry as you can and use that to improve your system. I think that's the main thing I took away from that. Otherwise, I rather prefer working for a small company like Kadena than any big tech company.
It's much less data to deal with.
It's just a different, there are people who like probably big organizations. There are people who like small companies. I prefer working at a small company like Kadena. Well, we see we are growing a lot currently. It still feels startup.
It still does. We haven't really adopted any of the sort of paradigms of, project managers and all that stuff.
Yeah, and one thing I really like is we are still very, driven by technical needs. Safety and security and correctness is really important if you build a blockchain. So there's not the situations that a program manager tells you, oh, we have to ship that. Can you make this shortcut? I know it. Something will break. 1% of the customers won't be happy. But we just need that out. This product has to ship. With a blockchain, that just doesn't work. There's too much on stake. Chainweb breaks, people lose money and potentially a lot of money. So there's always, we rather don't roll out anything and get it right and spend another 3 weeks of planning and thinking about it, or maybe rewriting something from scratch instead of releasing something just because we have a deadline and some skip level manager needs this product to be shipped. So that's something that as an engineer is very nice about blockchain, because I always have a good argument to convince my manager that I really have to spend more time on this.
Fair enough. Yeah. All right, so we have one from, let's go with Windfair's question. What are the plans forward to market KDA to the world, and how do you think KDA will change it?
I'm not sure. Maybe that's more a question for you, Emily, working in Pact. And
well, we want everyone using Pact, that's for sure. And we want everyone using Chainweb that needs to use Chainweb. And we do have a strategy that involves, for instance, focusing more on layer 2 and using Chainweb as a settlement layer for various projects. So things like the zero knowledge stuff that we rolled out. We plan on integrating into our layer 2 strategy, in addition to various other things that will be coming. And I'm going to tease a little bit here. We're getting sort of WebAuthn and user authenticated sessions built into Pact in a way that allows you to kind of own your data and you to publish your rollups at the sacrifice of obviously some centralization in order to, and using Chainweb as a layer 1 publication.
And yeah, I'm not completely sure how much this question is about Kadena or the token KDA specifically. If it's about the token, we see KDA as it's essentially the infrastructure token. It's a token that miners are paid in, that gas is paid in. I think that's really the main focus on the main reason for KDA. It's providing the infrastructure. So we may not market KDA directly. And I think I'm not so much into business and follow that much, but my impression is that we are not pushing KDA as a token that hard. There's really zero discussions on people on a daily basis within Kadena about the value of the token. So I think many people never look at it. I don't know. But so we see kind of driving kind of adoption for the Kadena network by having people build on it, building their own tokens, building their own infrastructure, building their own services on top of it. And KDA is a token is just a thing that runs infrastructure. So it will be useful just by other people building on top of it.
Thank you. That's a good point.
But that's my perspective. So I'm not necessarily a person who knows about business strategies or so. That's more like what my impression is from what I see.
Fair. Maybe we need to get the eco people in here.
Yeah, so they probably could answer those things in a more authoritative way.
Yeah. Okay, just to highlight one question that we should probably answer. Do you think the technology and popularity of Kadena will lag behind other layer 2 projects? No, Kadena is going all in on layer 2. We are focusing extremely hard over the next year to focus this as our sort of primary market strategy. So you will see more layer 2 work coming out of Kadena over the next year, year and a half, 2 years.
And sorry.
Yeah. We will hit this head on as the wave hits.
And one has to say we've been looking into the related technology since a while. We looked into everything that is happening on the zero knowledge in the field and zero knowledge proofs. And the more we look at it, we have the feeling that we didn't realize that we have essentially a head start. We know already how to connect chains. We have 20 chains running and they are communicating and they're using, you can do already cryptographically safe cross-chain transactions. There's no reason why the same technology doesn't work between layer 2s and layer 1s or different layer 2s. So essentially we,
albeit probably faster.
Yeah, and we had done work even before with integrating with Ethereum. We had kind of 2 years ago we had this experimental bridge running. And all this technology was essentially based on what we have already, kind of namely SPV proofs on continuations and pact. And so I think we have a good head start there, and have a nice technology that is built into the language itself. It's not something that has to be built on top of it.
Fair enough. All right, Lars, just a sort of non-technical question that I think would be a good breather. From Jeff. For Lars, what excited you most about first joining Kadena? And has Chainweb evolved over the years since it was first conceived?
Well, I think I answered a bit of that already at the very beginning. So when I joined Kadena, there was essentially Stuart sold me on Pact mostly, and he sold me by just, one thing that was really impressed me was the formal verifications that they were doing at the time. So I have an academic background in formal verification. It's a hard problem, and I spend a lot of time thinking about how we can pitch smart contracts or how we can pitch formal verification to the industry. Convince people that we should really prove software correct. We shouldn't just ship them and then let the users deal with the bugs. I think Stuart comes from a banking background, so he knows what he does. And obviously they saw that smart contracts are really something where people are willing during development to pay this extra cost of proving things correct. Because if you have a bug in a smart contract, we all seen over the past years what happens. It's not like you roll out a patch and everyone is happy. By the time you roll out the patch, you lost millions and tens of millions. So it's formal verification is something that really matters for smart contracts, and that was something that Kadena did from the very beginning, and they built into the language, and it's not perfect, of course, because it's a very, very hard problem. It can't never be solved perfectly, but they go a long way. So a lot of stuff can be proven correct in a Pact smart contract. So that's something that attracted me to the company. The other thing is Chainweb, yes, and we implemented it. We spent a lot of time convincing ourselves that it actually works, what its properties are, that it scales. We did a lot of simulations and tests and work on it, but I think the basic idea is still the same, and part of it is already in the Bitcoin paper, but barely used in Bitcoin, which is SPV proofs. Kind of take SPV proofs, takes the idea of having expander graphs, which with a small diameter, and it's just putting the things together. And I think the basic idea is, or the design is still the same. So it's, of course, there are a lot of details when you implement it, so things that have to be solved. But the general idea is is elegant. It still hasn't changed.
All right, thank you. It's very poignant. Let's choose another one. Let's see. There are not many Chainweb questions pre-asked, so let's talk about some layer 2 stuff. Do layer 2s, this is from Mr. Kennedy B, do layer 2s work the same as ETH layer 2s, where we use it for months and then get airdropped coins, or do you just start and public buy?
Honestly, I can't really answer this question. Emily, maybe you do know more about it since you work on Pact. And so it's, from a technical point, I would say no. We have a technology. We don't, for example, depend on roll-ups and things like this. We have other means of, or we have support for ZK primitives if someone wants to build that and use it. There are certainly use cases for it, but I think so. By using our existing cross-chain features built into the language itself, we have something that, on a technical level, works different than what Ethereum layer 2s do. But on a more practical level, Emily, maybe you can answer that better.
Yeah, I think I haven't used any layer 2s on Ethereum, so I can't answer this technically. But I can say that Kadena doesn't do airdrops. We are not the same as Ethereum V2 in the sense that airdrops are kind of endemic to the proof of stake experience on Ethereum, simply because they need funds to keep people going. Because you can get trapped in the same sense as if you don't have funds to migrate data off a single shard, you need funds intermittently to help migrate that data, and they solve this by airdropping. Kadena doesn't do this. We have things like gas stations to help pay for the gas cost of transferring things across chain. So we keep the decentral aspects of the network, in the sense that if you were to migrate data from shard to shard, you wouldn't need funds on the target chain in order to do it. We've solved that problem with gas stations. So in a sense, we don't have to work in the same way as Ethereum layer 2s do. And as far as like whether or not you would just buy stuff, this really remains to be seen, because people haven't really been building layer 2s on Kadena. And mostly this is because Kadena hasn't really enabled people to build layer 2s in a sense.
Well, in a certain sense, we have layers 2. It's called chain 13, where almost no transaction happen right now. People.
Yeah.
We have 20 chains. If you find that chain 0 is too crowded and your transactions take too long to get into a block, just move some liquidity to chain 13 and be happy there. You will be almost alone. Your transactions will go into a block immediately.
Right. Yeah, one of the fun things about talking about this layer 2 story for Kadena has been that Chainweb is actually its own layer 2. You can choose the chain with the least congestion, and you will probabilistically get your transaction in faster than on other chains. So I think as we move towards a sort of multi-chain architecture for the user experience, where people don't have to worry about chains, we can automatically choose the chain with the least congestion and sort of do stuff there.
I think the main difference here is if you go to a layer 2, you usually want to have faster finality. So if you go to an empty chain on Chainweb, Chainweb is already pretty fast. So we produce a block every 30 seconds, which is, by the way, conservative. We could probably lower that a bit. But since we have that many chains, we don't care that much about, being 2 minutes faster or not. You anyway should wait a few blocks. So, but yeah, if you stay on layer 1, you get the security that it's mined. You have the high level of decentralization. But yeah, you have to wait. And there's a somewhat long tail due to mining to the distribution. Some transactions just take quite a while until they are in a block, and then you may wait another 3 blocks, so you might wait kind of 5 minutes or so. So a reason to go to layer 2 would be, to not having it mined, Not well, it's still mined, but not proof of work mined. So there would be no proof of work. So you would go to layer 2, where someone controls the production of blocks that can be on demand. And by the way, that is perfectly possible with the existing Chainweb implementation. So we have networks internally for testing that use that model. Besides that, it's really the same. You essentially sacrifice the security. You go and do your transaction on a different chain that is centralized, and only later settle back on the main chain. So something, only then you have it really settled. But you get speed on the for that. But technologically, it really isn't that different if you go to a different Chainweb chain or if you would go to layer 2. There's probably some more delay in transferring to layer 2 because you have to bring over that proof and probably need some form of oracle there. That is
fair.
But for a pact programmer, it should feel almost the same. So you do a cross-chain transaction essentially.
So just in the same vein, a short question from Jake on chain is: would layer 2 improve cross-chain transfer speed?
Well, if you have a layer 2 with more than one chain, this is perfectly possible. So that's one thing that Chainweb can do. We can scale also layer 2s. So if you need a layer 2 and right now, I think many people in blockchain don't think about it, but why you might build your business on a layer 2, and at some point you find out that your layer 2 doesn't scale. Chainweb can do that. And of course, if you scale your layer 2, you don't do proof of work mining there, you can be much faster. So we have networks that we use for testing transactions and Pact, where we produce blocks every 1.5 seconds or something like this. So you can get very fast on a Chainweb layer 2, even a Chainweb layer 2 that has many chains. So you could think of having a layer 2 network with 20 chains, so you can get a lot of throughput in there, and you would get very fast cross chains on that layer 2. Going between layer 1 and layer 2, that's probably something that would take at least as long as a cross chain on Chainweb, I would guess. No, it doesn't have to, but it really depends a bit on the exact technology and security that you want there. But yeah.
All right. Thank you, Lars. So I'm going to get to some mempool questions in a second, but I want to spread it out a little bit and answer a question from Cloud first. What is the best, in quotes, feature you've worked on at Kadena and accomplished?
Oh, I don't know. I'm not sure if I worked on that feature. Probably other people worked on it. There's exciting stuff happening in Pact that I haven't worked on. But and as I said, the basic design was developed even before Kadena was founded, I think. Will and Stuart had spent many years in essentially developing the ideas that finally kind of manifested or kind of got realized in Kadena. So, but I think implementing Chainweb itself. So there are a few things that were challenging in there, particularly when it comes to in the consensus kind of, if you just, we had the basic idea that we would just slam together 20 copies of Bitcoin and everything would work. And it's not that simple. There's to make sure that actually the chains kind of can build the spreading that they need. So Chainweb chains are connected in a certain way that gives them enough freedom to kind of grow at their own speed. And at the same time, they have to be constrained to kind of have cross-chain transactions work, and also have the proof of work weight travel between chains so that we get the security that we need. Kind of implementing that was surprisingly tricky. And yeah, that was an exciting thing to work on. And it's something that unfortunately we haven't yet had a chance to carefully document or documenting outside of the code. The code that does it is very carefully documented. But I think once we have time, we really want to write a paper about it and kind of describe that algorithm, because I think it's a very interesting aspect of Chainweb that, if at this point, it's kind of when you hear about a cut. the term cut appears in several parts of the API. The concept of a cut is something that is it's a very core of the implementation of Chainweb, and it's currently documented only in the code. So if you're interested, you have to dig into the Haskell code and read it. And yeah, we should document it somewhere elsewhere.
Yeah, it'd be fun. All right, let's just get into the mempool questions. Everyone's been asking this for a while, and I wanted you on specifically because you have the brain for the mempool. You understand it the best of anyone, I think.
Although I didn't implement it, but I did quite a bit of maintenance work on it. And
just for the lore purposes, the person who implemented it was a person named Greg Collins, who left us in 2020, who was a senior infrastructure engineer at Google.
Yeah, he was at Google. I don't remember what exactly his role is, but he understands algorithm.
He was optimizing, I think, file copy or something like that.
Yeah,
which is very cool. Anyway, just to sort of group these together, we have a question from Casual Mining, mempool suggestions, ? And a slightly more coherent question. Is there any plan to make transactions get into the blockchain faster or get into blocks faster after being submitted to a node?
Now, finally, some questions where I have the feeling I'm really the right person to answer them and where I can be specific. But as I said, I didn't implement the mempool, but I looked into a lot of data, and this topic comes up over and over again. And the sad news for users at this point is the mempool works as specified and expected. That doesn't mean that it can't be, that we can't make it faster, but in the realm of the current kind of design and how we designed it, it's actually working as it should. And one thing people should be aware of is there is only, I would say, on average, half of the time that the transaction takes from being submitted until it is included in a block that is mined and propagated from the network. Only half of the time is actually spent kind of in the mempool or propagating throughout the network. So there's a time essentially where, let me quickly walk through what happens. So you submit a transaction into the network. The transaction then is synchronized to neighboring nodes. That's a peer-to-peer network that is essentially a random graph where things are gossiped around. So in theory, it should kind of grow exponentially, kind of the number of nodes over time that are aware of a transaction. At some point, it reaches a mining node. And when it reaches this mining node is currently already working on a block that has to be mined. So we can expect that it has kind of, let's say it arrives right in the middle, halfway through mining the previous block. So we have to wait half block time until this transaction even is included into the next block. But then that block still has to be mined. So that takes another, on average, 30 seconds. And when the block is mined, it is kind of sent throughout the network. And that goes relatively fast because propagation of new blocks is kind of prioritized in the network. So it goes pretty fast. But there's at least, on average, 45 seconds that a transaction is just kind of spending in mining, essentially, not propagating through the network. And that's that's pretty exactly what we measure when we look at kind of actual transactions and actual telemetry. We see that transactions usually take between 60 and 90. There's a distribution there. It's kind of has somewhat a long tail, but I think the median is somewhere around 70 to 80 seconds that a transaction gets included. Also, if a transaction skips some blocks, that doesn't necessarily mean that it takes longer because many blocks kind of are mined very quickly. So if you look at the block distribution, it's kind of like some exponential distribution. So there's a long tail. So some blocks take really long to mine. But in order to make up for that, a lot of blocks mine really, really quickly. Those blocks that mine quickly within just a few seconds, it's very likely that the transaction skips those blocks because it's just still, being propagated while those blocks are mined relatively quickly. So there's an exponential distribution there. And when people are, my feeling is, or my impression is when people are confronted with exponentially distributed processes like mining, they tend to think it's luck. they tend to feel like something is biased against them. It's like, you roll a dice and you wait until you roll a 6. It always feels like you're either lucky or unlucky. Mm-hmm. So the same happens with mempool. So actually, when we measure it, it's just what we expect from, how mining works and how gossiping in the network works. That said, there are ways to make it faster. One thing is, this mempool is a decentralized mempool. We have to build in a way that it works under the worst conditions. Let's say the mempool the network is completely spammed. There's a DOS attack going on. Things still have to work. So we don't want the mempool, for example, bring down the whole system by producing too much traffic. It's totally fine if someone wants to build a centralized mempool, just as a service in addition to the existing one. They could deliver transactions within milliseconds through a mining node. It would still have to wait for mining, but it's really, actually, this is also one reason why we don't over-optimize mempool, because we really expect that people at some point will start implementing their own mempools. They might take a fee for delivering things more quickly, but there's, make a deal with mining pools that they prioritize your transaction. You might think it's unfair, but there's really nothing we can do against it. People are totally free to build their own mempools. Mm-hmm. What we try to do is to build a mempool that has lower priorities and consensus. So the important thing is, if the mempool isn't optimal, things get slower, but the network still stays in consensus. So one thing we really want to avoid is that, we get forks in the network because the mempool takes too much bandwidth. So therefore, we are very careful on optimizing the mempool. But there are things we could do. Another thing, by the way, we could do is optimize mining, that miners update their nodes, their blocks while they're mining. So if a new transaction comes while a miner is mining a block, we could preempt that mining and give him a new block to mine on that includes new transactions. That's something we don't currently do. We could do, and it would speed up things. Let's put it hasn't been a high priority for us, because we think 80 seconds, 90 seconds on average are fine. And then you wait a few blocks anyways. For example, if you make a transaction with an exchange, they probably require something like 10 blocks. So you anyways wait another 5 minutes. So it doesn't make that much of a difference. But yeah, there are ways to optimize it. So talk to mining pools, and send your transactions directly there.
I think
or submit a patch on GitHub for the mining loop. That's another thing. It's open source. So look at the code, make a pull request if you're a developer. There are ways it can be optimized. It just hasn't been such a high priority because the actual distribution is what we would expect with the current design. Mm. That was a very long answer, a little technical, but since it comes up that often, I hope it kind of answered a bit, our reasoning behind it. So it's in part that we prioritize in Chainweb safety more than performance. And in the other part, it's that we think there's a potential market there for people building their own mempools.
Yeah. Just for everyone and their own edification, a mempool has one thing that it's really supposed to do, which is optimize for a miner economy, right? And depending on your use case and the things you want to supply people, you can change that economy in a variety of different ways. And we don't want to be the sort of, a sort of monolith in the sense that we provide the only mempool that's available. There's an API, it's spec'd on Chainweb in our docs. And if you want to read how to get involved with it, how to write your own, you can choose any language you want. It's just an API.
I have to caution a little bit. We would like to make really an API that makes it easier to write customized mempools. Currently, on the code level, that isn't there. But of course, there is an API, the peer-to-peer API, the way how nodes talk to each other. You could definitely write something that talks directly to the mempool and injects transactions there. You have to be careful. This API also, right now, we don't guarantee any stability. If you write something against it, please don't complain if things break. So the service API, that's the thing that Pact is on, that you talk to, your applications talk to, that's stable. But the API that nodes talk to each other, we don't provide the same level of stability. So if you program against it, be aware that things might break, might change. We might change the defaults for throttling there and rate limiting, because consensus has priority. The priority is that blocks are produced, this network is stable, and there are no forks. But if you work on something like this, talk to us, and we are happy to talk about adding stable APIs. We make pull requests, file issues, and if you have an idea and want to work on something, or you depend on certain APIs and you're afraid that we might break you, let us know. So Chainweb is open source. Everything in there is open source. All pull requests, all reviews that we do, everything is open source. You can see it. You can see what's going on. Transparency is really, really important in a proof of work blockchain. In the end, it's not us who decides what runs in the network. It's the miners who decide, and the validators. So we just propose things there. We release a new version, and in the end, we can't force anybody to run that software.
Fair enough. Thank you, Lars. That was a very detailed question and answer. I have another one in the same vein that is slightly different. From Piranha, are there any places where the 20 chains can get bottlenecked in terms of finality for layer 1? Are there any concerns for dApps?
Bottleneck.
This is a tough one.
Yeah, I don't. Well, one thing that certainly happens is everybody uses chain 0. There will be a bottleneck on chain 0. Kind of mining will go on, so it's not possible that one chain holds back the rest of the network. If transaction processing on one chain is congested, blocks are just full, probably gas would go up. But at some point, the mempool will drop transactions. If there's too much backlog, the nodes will just throw out, low priority transactions. So you will see your transactions just disappearing. You will have to resend them. But there's always a chance but it's not possible that one chain can kind of cause the whole network to stall. There's always progress there. So you could always just go to another chain. And how you would probably do it is you deploy your smart contracts on more than one chain and make sure that you distribute liquidity, so that you have the liquidity that you need on every chain, and build a load balancer in front of it that moves your clients to a different chain. But I'm not completely sure if that answers the question. So is it more like what would happen if all chains are congested?
Yeah, let's suppose that scenario. What happens when in the massive success, Kadena is up at $1,500? Everyone's using it. What happens?
Well, in that case, we would scale out. That's something we did in the past, and that was important. So at the time, we scaled from 10 to 20 chains. We did a small jump because, as I said, every chain we add creates a constant overhead. So it has to be justified. We don't want too many empty chains just dangling around, consuming empty database space. But we did it in order to prove that we can do it and have the technology to do it. So if we get completely congested, the first thing that would happen is that gas prices would go up on the chains, which actually would be good, because currently gas prices are just essentially non-existent. Which
too low.
Too low, which means that people can front run your. It's very cheap to front run, a reasonably large amount of large amount of transactions. So gas prices would go up, which isn't bad. It wouldn't get crazy like Ethereum, Bitcoin. It would just go up to a reasonable level. At the same time, we would just scale out to more chains, and that's something that would take a few weeks or months, because we would probably do it with a service date, kind of with this kind of fixed dates where we kind of ask miners to upgrade their nodes, or anybody in the system, which means that kind of everything goes, we would have to roll out a new version. It's in order to go, let's say, to 100 chains, that's we would have to change the code. But we would expect that everybody would be happy to take it, because we would only do it if there's demand for it. If there's enough traffic, there's enough utilization of the existing chains, so that everybody would be happy to take that code change that would migrate the system to, say, 100 chains or 500 chains.
Thank you, Lars. I think that was a concise answer. Let's see. I had one up here. Yes, here we go. From Crypto with Brian, do you think that proof of work will fall behind new mechanisms like Hashgraph, proof of stake, etc.?
I'm not sure. I'm careful with kind of judging about other or giving opinions about competing consensus mechanisms. I think proof of stake, I'm happy to give some opinion because I think it's not only a technology question. It's really a different kind of consensus. Proof of work is inherently open. So if I run a proof of work, I'm a miner in a proof of work network. I can't prevent anybody, on the other side of the world building some hardware joining the network. Proof of stake is different in that. Proof of stake, in order to join the network, become a staker, I have to buy the currency. And if the people who currently have the currency are not willing to sell it to me, I won't be able to enter the network. So the network is decentralized, but it's decentralized in a controlled way. It's kind of the people who have already control have to be willing to give up some control to create decentralization. So it's essentially decentralization that is controlled from within. Proof of work is decentralization that is really completely open. There's no way to keep your control if someone else, decides to build hardware and spend energy in going into it. So in this sense, I think proof of work will always be a bit different from proof of stake. And there are, I think, very good arguments for why a proof of work network makes sense and is useful and has something that proof of stake doesn't have. For Hashgraph, I don't know enough. But as I said, I see Chainweb as a very conservative and elegant extensions of Bitcoin. It just adds enough to make Bitcoin scale. And Bitcoin itself is a very simple, kind of elegant consensus algorithm. I think, that's what I can say there. It might be that for certain scenarios, proof of stake is more attractive. I have my issues with it. I think it looks a bit like, our current banking world, or how our current banking world already operates, just with a different label on top of it, and maybe now merge these and a slightly different technology to secure your database. But
all right.
But that's a personal opinion, so that was not so technical. So
I would like to point out a little bit of some FUD that goes around constantly, which is because we are a braided sort of layer one with proof of work mining, there's this idea that if any one chain goes unmined, then all chains eventually stall. Do you want to? I said a little bit something.
I see. Yeah. No. We are not a DAC in the sense that So Chainweb operates more like a single chain. It's a single chain that scales in a certain sense. So it's not that chains are not that independent. It's kind of technologically we scale them. It's sharded kind of, but it's one KDA on it, and the security is distributed between all chains. Kind of there's no such thing that miners can focus on one chain. There's no incentive for miners to focus on a single chain. So the system is very carefully designed that miners will mine essentially randomly across all chains, and they're incentivized to do that.
Yeah. I would like to note too that there is no situation where a chain goes unmined. That's basically a free mining scenario for any miner that chooses to mine it. It basically means there's no contention, which means it's free money, effectively, for mining that block. You have no competitors. So in a sense, this isn't like a rational situation that you see in the real world, because there's not a miner scarcity in Kadena. There's a miner abundance right now. There's contention for blocks.
Miners mine across all chains, and that will probably be the case until we scale to a really large number, and then it will still be that miners pick randomly what chains they mine on. So there's no incentive for miner to focus on one chain, and difficulty is shared between chains. So difficulty, mining difficulty travels between, those chains are really braided together. and act kind of like a single chain in terms of security and.
Although you will see some dips in difficulty, in the sense that it will be slightly easier to mine chains that aren't discongested, right?
No, I don't think so.
Oh.
Difficulty is adjusted kind of in an. There might be small.
Very small, isn't it? Because like you have some blocks that are slightly ahead or slightly behind, or some chains that are slightly ahead or something.
But that's just random. I haven't looked into that a long time, but I'm pretty sure when we did a lot of research in how difficulty adjustment is designed, which essentially incentivizes miners in picking chains. And if you're a miner, pick your chain randomly. It's the best thing you can do.
Right. All right. So we have 5 minutes to go, just to give a time limit. I thank you so much for answering all of these questions, Lars. This has been, I think, the technical dump that people really want to hear from us. I suppose we can pick one or two more questions and call it a day. But to be sure, let's just let's see. Let's answer this one. I think this will be the last question because we have actually 4 minutes left now. But do you guys want Kadena to be the crypto that runs stock markets in the future from Windfair? What do we think?
What do you think?
I think, yeah. I mean, if you look at the settlement times for buying individual stocks, it's something like, what, days? You know, people writing slips and stuff, or at least digitally settled over the course of like the end of the business day. And I think one of the things that people seem to forget is that, you know, being able to reserve and settle within a minute and 30 seconds is actually really phenomenal in terms of things like, you know, the stock market, some other types of assets, right? I wouldn't say we're fast enough to handle, say, credit card payments, but we have a layer 2 story that we're building to handle things like that, where you need like instantaneous confirmation and then slightly slower settlement. So can Kadena, run the stock market of the future? Yes. Can it handle the credit card scenario? Not yet. And that's what we're building towards. So we want to make things like payments and fast settlement, not necessarily finality and confirmation, fast confirmation and, deferred settlement and finality, a thing, which currently we don't have. Right now we have I think, the most scalable, relatively quickly finalizing blockchain in the blockchain space. That's it. And by blockchain, I mean blockchain in the sense of it's actually decentralized. It's actually, it has good incentives. We don't, aren't beholden to like VC and that kind of thing. So, yeah, I think we're doing okay. Yeah, we're at 2 minutes now. I don't see any questions that we could really answer in a meaningful time frame, but I think it would be okay to cap it here. So thank you so much, Lars, for coming on and answering all these questions.
I have to apologize. My perspective is necessarily more on the technical side, so I hope I wasn't too boring for people who are not into the technical details, but
it's okay because we're doing this every week. So, we'll have Eco on one week, we'll have Stuart on another week, we'll have, me and Doug or John on another week. So just being able to diversify our output here in terms of technical things and then business things and then, building things, it's all good. Thank you so much for coming.
Thank you for hosting.
I'm happy to host this again. This was fun. But I imagine you'll see Tyler most of the time. So anyway, thank you, everyone. And have a great day. And I hope Kadena goes to 1,500.
Bye, everybody.